Okay, Bio30, welcome back. If I'm not mistaken, I think we stopped here at the accessory glands, so we're going to continue on and hopefully wrap up with this section of our notes here. So, we have various organs in our body for this organ system, for the digestive system, but there are also a couple of organs that kind of help out. They're not directly involved, like not directly along the digestive tract, but they're along the way. They're accessories to the actual digestive tract itself. These include the pancreas, liver, and the gallbladder. The pancreatic duct is going to connect from the pancreas, and the common bile duct is going to connect from the liver and gallbladder, and that's going to all enter into the duodenum. So that's this area right here. There's your pyloric sphincter. So your stomach is over in this area here, just under where it says common bile duct. But then into this space here, into your duodenum or duodenum, depending on what you're calling it, that's where all of our ducts are going to open up. So let's try to find out what we can do with each of these, starting with the pancreas. Pancreas is very deep inside of your abdominal cavities. Remember, we talked about deep meaning very far inside of your body. So you're going to find your pancreas inside, just underneath of your stomach. And if you take a look at it, it's a bit of a long, like it's a narrow bulge, I suppose. It has a couple of different features to it. The pancreas serves a role in a number of different systems. So it helps out in the digestive system, which is what we're covering right now, but it's also got some other features. For example, it works with the endocrine system as well. So we'll see that one again at some point. A couple of things that the pancreas can do is it can secrete some chemicals like insulin and glucagon. These are going to be hormones, so directly related to the endocrine system in particular. But when it uses these exocrine features instead, or as exocrine functions, that is more related to the digestive system. So most pancreatic cells are going to produce what's called pancreatic juice, and it has sodium bicarbonate, basically just baking soda. So our pancreas is producing some baking soda and a little bit of these different digestive enzymes, and that's going to be useful for taking down the food. The sodium bicarbonate, as you can probably guess, you're coming from the stomach, which has a lot of acid squirting into your small intestine. And sodium bicarbonate, baking soda is the opposite of an acid. It's a base, so it neutralizes that. You probably don't want acid inside of your colon. So it neutralizes the acid in the chyme, and that way you don't have something that's going to burn through your digestive tract as it goes through your small intestine. You also release this stuff called pancreatic amylase, very similar to salivary amylase, which you found in your mouth. This is going to help digest those starches that are there. We're going to have some trypsin, which is going to help us digest proteins, and lipase, which is going to help us digest fats. The biggest organ in this, or biggest accessory organ, is on the upper side. So it's on the right half of your body. That's going to be your liver. Liver also has multiple roles to play. This is the largest organ on the inside of your body. So your skin is the largest organ of the body, but inside of your body, it's going to be the liver. And it's close to your stomach. It's just on the right hand side instead of on the left, just underneath of that diaphragm muscle. The liver's got about 100,000 different lobules, so little chunks that make it up, and that is going to be its initial functional unit. So most of our organs they have a functional unit on the inside that helps us identify how that organ is going to work. The liver's got 100,000 of these, so it's a really big system. Each of these lobules is consistent of what's called a triad, so it's got three different parts. Part of that triad is going to be a bile duct. That's going to take bile away from the liver. We'll talk about that in a second. We're also going to have a piece of the hepatic artery, which is going to bring oxygen into the liver. And then there's the hepatic portal vein, which is going to help transport nutrition away from the liver. Central veins of the lobules are going to enter into a hepatic vein, and then blood is going to travel from the intestines to the liver through the hepatic portal vein, and then from there to the inferior vena cava, and eventually into your heart, so they can get reoxygenated. So it just completes a cycle. In case you wanted to see what that looks like, just another view where you can see the vein itself. You got to start at the bottom. Small intestines are going to absorb various products. The nutrient molecules are going to travel into this hepatic vein into the liver. Liver monitors the blood content, and then blood is going to enter the general circulation through the hepatic veins, empty directly into the vena cava. And then the vena cava is connecting into your heart. So then that gets reoxygenated, the blood gets resiphoned around your body, and then the whole cycle starts again. Now the blood, I'm sorry, not the blood. The liver is considered the gatekeeper to the blood. So any way that things get into your blood, they have to get through your liver first. And it has a whole bunch of different roles it's going to play. For instance, it's going to detoxify the blood by removing any of these poisonous substances. It will send them off to your bladder so you can pee them out. Your liver is going to store various iron ions. So if you have excess iron, maybe for hemoglobin, you might have those there, and also some fat soluble minerals are going to stick around on your liver also. We're also going to make some albumin and fibrinogen, which are plasma proteins, so proteins that are going to sit around in your blood plasma. And we're also going to store glucose, but we're not going to store it as glucose because that gets converted into energy, or glucose is used for that cellular respiration. Instead, the glucose is going to be stored as a glycogen. And that's immediately after a meal, and then the glycogen will break down the break down to glucose so that we can keep this glucose concentration when we're not eating. So it makes sense when you're eating, you have glucose, so you don't need to really use all of it. Some of it is stored for later on, and later on when you're not eating, you can re-break down this glycogen back into glucose so that you can constantly have some supply or some source of supplying that cellular respiration. Our liver is also going to produce some urea, which is one of our nitrogenous waste products. We're also going to break down amino acids. So amino acids, they tend to break down into nitrogenous compounds. For us as humans, it's going to be urea. If it's a bird, it's uric acid. If it's a fish, it's ammonia. But we do also produce those in small quantities also. We'll talk more about that, though, in the urinary system. We also break down, and not really break down, but remove bilirubin from our hemoglobin. That is that brownish reddish color that our blood gets. So that is going to be broken down so that we can get rid of that. And at the very end, we're going to try regulating. We're going to try regulating our blood cholesterol level by converting that into some sort of salt. That really depends on how much cholesterol you have. Our diets in North America are so bad that quite often we have too much of this cholesterol, so our liver can't handle it, but it does its best. And if it works, you function pretty well. If it doesn't work, that cholesterol cannot be regulated fully, and that starts to make your arteries stick on the inside. And that's a bit of a different issue that we're going to talk about later as well. So a couple of things that can go wrong with your liver, considering it's such an important role, even though it's just an accessory organ. Things like hepatitis and cirrhosis are two major things that are going to mess up the entire liver itself. And that's a problem because the liver can repair itself, but if you have hepatitis or cirrhosis, you've kind of blocked that ability entirely. So if you have any of these situations going on in your body, it's life threatening. You need your liver, and if your liver is not functioning, you can't function. If you have a liver ailment, you sometimes get something called jaundice. So jaundice, you get this yellowish tint to parts of your body. So your skin might shift a little bit to this yellowish color. If not, your eyes will start to get this yellowish tint, and that is an indication that you might have some sort of liver disorder going on. So we mentioned bilirubin, which is the byproduct of hemoglobin molecules. That is going to be deposited into your skin, and then if there's too much, it'll go into your blood as well. Jaundice can also result from hepatitis. So that's a situation where your liver starts to swell up. Obviously, that's not good because it can't fit in the cavity anymore. So we take a picture of what that looks like. It's pretty gross. You can see all the yellow fat bubbles all over top of that liver. Hepatitis is going to happen in a couple of different ways. You can get Hep A. This is usually coming from contaminated products. Often it's sewage, it's waste products. So not that anyone's necessarily consuming waste products, but let's say you go swimming at a lake and there is a dump off of some sort of sewage nearby. That could be an issue you have. Or if you're in a country where the regulations for sewage runoff aren't very great, you got to be careful where you're swimming because um, a body of water could have a very high concentration of sewage contaminated fluids. You get Hep B as well. Hep B is an STD, so that comes from sexual contact. You can also get that happening through blood transfusion. So if you get blood transfusion from an infected individual, then you would also get that because it's in the blood. Or people that are using needles. First of all, it shouldn't be a thing, but if people are using needles and someone was infected with Hep B, then as soon as that needle goes into another person, they're also infected with Hep B. So a couple of situations where it's entirely avoidable, but you need to make some wise decisions about how you want to work with Hep B. There are some vaccines that you can get that are going to limit the spread of hepatitis B, so that's useful if you need it. There's also what's called hepatitis C, and this happens when you're contacting infected blood in particular. This can be really bad. Like it can lead to chronic hepatitis. It can cause liver cancer, and if any of these things get out of control, it leads to death because you need your liver. Hep C, you got to be careful with when you go traveling because if you're not insured for the treatment, it's something that you can like totally unexpected. Let's say someone has Hep C, for example, and they go down on the beach somewhere in Cuba, and there's some glass shattered on the beach. They step on it, ouch, their foot bleeds a little bit, and now there's a little bit of blood on that glass. It's on the beach. And then you go by that beach a little while later and you step on that piece of glass as well. You accidentally cut your foot again, ouch, but there's infected blood on there. You potentially could get Hep C from that. So it's a really scary one. It's one that you want to be aware of. And just be smart about, be aware of your surroundings, be aware of where you're going. If you go to a place that has a high volume of Hep C patients, that's something just to keep in mind if that's something you want to think about. Cirrhosis is another chronic issue that you can have with your liver. Essentially, liver gets really fatty and it's replaced by these scars all around. The scars can't do anything, so they're just covering up your liver, which is kind of annoying. Cirrhosis of the liver, you often see in alcoholics. If you're an alcoholic, then it's like your body's focusing on detoxing the alcohol, so there's no control over where that fat's going. Because of excessive alcohol, which essentially is a toxin, as the liver breaks it down, the liver itself breaks down. So that causes a lot of issues. Your liver is unable to work with the fats as much. Your liver can regenerate itself. So if it's got a regeneration rate that is higher than the rate of damage, no big deal, right? Your liver is going to take some damage, it's going to repair itself. But if that is exceeded, then there's not enough time to let the liver heal itself. And then in that situation, your liver starts to die. So just a couple examples of what cirrhosis might look like. You can get liver transplantation if you really need it. It's a possibility. You can also get artificial livers. They don't really work yet, but our technology is getting better, which is kind of nice. One type of artificial liver that you can get is a cartridge. It's kind of like stem cells, but they're liver cells, and we can insert the liver cells, and they'll start to grow into a regenerative liver in your body. The way that works is a patient's blood is going to pass through this catalyst of cellulose acetate, and the cartridge is a part of that. So that way, your blood is mixing with, or the patient's blood is mixing with the cartridge, and then those new cells are coming into the liver, and then they're going to regenerate themselves. We've also got a gallbladder. The whole thing should be purple, not just everything, but the art. Gallbladder is really teeny tiny. It's a pear shape. It's a small muscular sac, and it is just next to the liver. It's actually attached to the liver. Your liver is going to produce about 1 kiloliter or 1,000 milliliters of bile on every day. And any excess, if you have any excess of that bile, that is going to be stored inside of your gallbladder. So if your liver produces more bile than you really need, it goes into your gallbladder, and your gallbladder holds on to it for you. Water tends to be reabsorbed by the gallbladder, so if you do that, bile becomes very thick. It becomes like mucus inside of your small intestine. And when the bile is going to leave, your gallbladder is going to connect that to the duodenum via the common bile duct. The cholesterol content of bile can sometimes come out into the solution, and that's going to cause it to crystallize. So if you have a high amount of cholesterol, this is one of those situations where, if your gallbladder is storing bile, then it's also going to potentially store some of that cholesterol. And that can be a problem because they can crystallize. If that happens, they can also grow. And if they grow too large, you get what are called gallstones. The passage of gallstones from the gallbladder might block the common bile duct. And if that happens, you can't get bile into your small intestine. And this is what's going to cause what's called obstructive jaundice. So you got jaundice, but it's because something is blocking the pathway of bile. In this situation, your gallbladder should be removed. That's a surgical procedure. So just like getting your appendix removed, but it's your gallbladder instead. Okay, so you can get gallstones. Chances are you might have teeny tiny ones in there, but they can change. They can be redissolved if you don't have too high concentrations of cholesterols. But if you do have higher concentrations, the gallstones will sit in there and eventually they'll block your common bile duct. Couple of digestive enzymes to be aware of. Digestive enzymes are hydrolytic, which means they're going to break down larger molecules with the introduction of water. The water is going to come in at very specific bonds, and that's going to help break down those molecules. Other digestive enzymes are going to be proteins, and they have a very specific shape that's going to fit the substrate. So each enzyme is for a specific product, and you have most of them. Sometimes some of your foods are going to help you produce them, or some of the things that you get into your body are going to help you produce them. But for the most part, your body has capability of producing them. Enzymes also have an optimum pH. So if you have the right amount of acidity or basicity for the enzymes, that's going to keep them functioning faster and more efficiently. But if you get too acidic or too basic, then perhaps their efficiency starts to go down. Eventually, they become denatured and they don't work. So you want to make sure that you have a pretty optimum pH. Your body handles that pretty well. A couple of other digestive enzymes that are present in digestive juices can help break down carbs, proteins, nucleic acids, fats, which are going to be the major components of your food. So there's a list if you want to see them. You can take a look. I've got a whole bunch of the enzymes listed on the left-hand side. Tells you where you can find them, where they're produced, and then where they're going to activate. You'll also know where or what the pH should be in these regions. So most of it is going to be basic, which makes sense because most of our body is basic, but in a couple of specific places like the stomach, you'll see that it's going to be acidic. There's a reaction that happens for that. When we get into the nutrition, well, this is talking about what gets into your body. So what is the point of digestion? Well, you need to get certain nutrition into your body. That's going to help your body function. So we need to be aware of the different things that you can get. A nutrient itself is going to be a component of food, and that's going to give us some sort of physiological function in our body. And there's 6 different classes of these. We have carbs, which are short for carbohydrates, fats or lipids, proteins, vitamins, minerals, and then water is going to be considered a nutrient also because we need lots of water in our bodies at all times. Nutrients in our diet, they have to provide us energy, promote growth and development. So they're going to give us the energy to function. They're going to provide us with the ability to grow into a larger mass of cells if necessary. If not, it's going to help parts of our body develop. It's going to maintain that fluid balance, help with that concentration gradient. It's going to maintain that proper pH so those enzymes can function at optimal levels. It's also going to regulate cellular metabolism. So make sure we're having the right amount of energy at the right amount of time. So we'll take a look at a couple of these. Carbs in particular and fats are going to be the major sources of energy in the body. We'll use proteins for energy. Proteins are good for energy because they last a very long time. Carbs, on the other hand, are very fast. So carbs are good for fast energy, but you get tired after having carbs. Fats are also great for energy, but there's storage. You need to do a lot of work to get the fat converted into energy. Proteins are long-term energy, so this is really good for growth and development. It's good to have protein in your body for that reason. A couple of vitamins and minerals. Proteins are going to help with regulating that metabolism because most of the enzymes you have are proteins anyway, so that's going to help out. And then water, as mentioned, is pretty necessary for metabolism. That's because the content of your cell is almost entirely water, so you need to have that content in you, and that way you can be helped out by the transfer of water one way or another. A couple of the food choices that you have, your diet choices, are going to help build your diet. We do have a dietary recommendation in Canada. We use Canada's Food Guide, and there are nutritionists and dietitians that are hired to come up with Canada's Food Guide. You have to be careful because this is a government product, a government idea, and quite often government is swayed by political pressure or lobbyists. So, for example, if you are a dairy farmer in Canada, which there are a lot of, you're probably not going to give your money to the government if they're not going to promote your product, right? So you're more likely to see things like dairy on Canada's Food Guide because we have so many dairy farmers. So you got to be careful. You have to use both. You can use Canada's Food Guide as a starting point, but also use your own intuition as a science student. Learn how to research and pick apart the things that are actually good for you and the things that might not necessarily help you out. And I'll show you what that looks like. I'll tell you right now, as of 2021, the Canada's Food Guide is actually pretty good. They've ignored a lot of the lobbying from various other exterior groups, and they've used a lot of science to come up with what they've got. I'll show you about a couple of these different components. Starting off with carbohydrates. Carbohydrates, they can be complicated like breads, pasta, but they're easily converted into glucose and other sugars if necessary. Blood cells or body cells can utilize fatty acids as an energy source, but your brain in particular needs to have glucose. So it's good to have some sort of carbs that can be broken into glucose so your brain has some fuel. Simple carbs, these are things like table sugar. They give you some energy, but they're going to also give you some weight gain because there's so much energy that it just gets converted into adipose tissue and that's just stored on your body. Which I mean, it is good because later on, if you need it, you have that energy stored on your body. But if you don't need it, if you're eating sugars and you're in a pretty stable environment where you don't need to be fending for your life, then those sugars will be converted into fats and they'll be stored on your body. And that's what's going to make you look a little bit chubbier around the waist because you have extra carbs in your system. You can get some fiber in your body as well, which could help you out by limiting the amount of time those substances are in your intestinal wall. Because remember, you need your intestines to absorb. So if you have fiber in your system at the same time, the fiber might block the ability for your intestines to absorb as much of the sugars. So having, say, a large fibrous meal with some carbohydrates is far more useful than just having carbohydrates because you get a little bit of the energy there, but a lot of it just gets excreted out with the fiber because it's blocked from being reabsorbed. Proteins are probably one of the best things that we can get in our body. Things like milk, meat, eggs, they have lots and lots and lots of different proteins. It's really good. They also contain 20 essential amino acids. We don't need all the amino acids, but 20 of them we do need in our body to produce all the proteins that our body needs. So as long as you're eating these products, you're going to be getting all of your amino acids. If you have a diet that does not include meat or eggs, for instance, if you're a vegetarian, there are other sources that you can get that give you these amino acids, but you need to have a variety of those foods to get those in. So things like nuts and beans are good for that. If you are on the vegan diet, then milk won't be something that is part of your diet. In which case, again, there are other products that help. Soy products are pretty decent for this. Some oat products are okay, and a lot of the bean products are like they're exceptional legumes, that sort of thing. Um, because individual vegetables don't have all the amino acids, as mentioned, vegetarians, vegans, you're going to have to do a couple of other things to get those products in. I forgot seeds. Seeds are also fantastic of getting those in. You just got to be careful with seeds and nuts because they do have large fat content in them. You also have to be careful because a large variety of people or a large number of people have allergens that fall into the seed and nut category. So just be aware of that. Also, recognize what's a nut and what's not a nut. I know that words like peanut and coconut have the word nut in them, but they might not necessarily be considered a tree nut, for example, like an almond or cashew. So people that have allergies to tree nuts aren't necessarily allergic to things like peanuts, which are a type of legume. So just just be aware of that. If you have allergies, maybe get yourself tested on that because there might be products that you can eat that you're totally unaware of because you thought they were something else. You need to have amino acids to build these proteins. We have no way of storing these in our body. So if you don't have storage for amino acids, you have to constantly have proteins so that you can replenish these. If you don't use them, you just get rid of them, which really sucks. It's like if I give you a box of Lego and you don't use all the pieces, well, at the end of the day, I'm throwing those pieces out in the garbage. And if in the future you want those pieces, well, you have to wait until I give you a new box of Lego. But that's just the way our body is right now. That's just the way that it's going to function. Something that we do store very well, on the other hand, are going to be lipids. So these are things like fats and cholesterols. Lipids are going to be those little fats and oils that we have. We should be really careful with these because they are very high energy, but um, they're hard to access unless you are doing some extreme, like, life preservation techniques. If you're out in the wilderness for a week with nothing, that's good to have lots of fat in your system. But if you're living in a house in North America, you probably don't need as much of these. This is where you're going to get that low density lipoprotein. That's going to take cholesterol to the cells, and that's going to develop plaque on your blood vessel walls. That makes your walls sticky and hard, which you don't want. Saturated fatty acids, they lack double bonds, and that increases LDL levels. You don't want that. You want double bonds so that it's harder to break down the fats, and then you can just access them as necessary. There are a couple of essential fatty acids that we do need. We need to have linoleic acid and linolenic acid. Those need to be in the body. We can't make them. There's no way of getting those, and we need them for various functions, production of certain enzymes, and storage of certain enzymes. So those you do need to have fats in your body to actually survive. And if you don't have them, then there's a couple of things that are not going to function. If those things don't function, then it's kind of a cascading effect. The rest of your body can't function the right way. But unfortunately, a lot of these things are things that we really like. So you'll find a lot of donuts with fats in them. Vitamins are also good for us. Organic compounds. Our body's unable to make them, but we can eat them. So a lot of them have parts of enzymes. You'll take a vitamin, you literally just attach it to another chemical, and then now you have an enzyme. So really good for us to have. They are just chemicals. We call them vitamins because of their necessity to the body itself. A couple of examples are ascorbic acid, that's vitamin C. Cobalamin, that's vitamin B12. That's an essential one for brain development. And then cholecalciferol for vitamin D3. So lots and lots and lots of different chemicals. There's names for every single one of them. There's so many of them. Be careful with vitamins that come from a pill bottle because we don't absorb all of them in the exact same quantities. If you can get them from foods, much better. If you're going to get them from a bottle, just you'll have to monitor. Maybe if you have a dietitian or a nutritionist that you're seeing, you can monitor your levels of vitamin retention because that's not the best situation for some of these. B12 in particular, if you're on a vegan diet in particular, a lot of the products on a vegan diet do not contain B12, so you have to take some sort of supplement, and supplements are often 1000% your daily dose because you're barely going to absorb any of that. But if you can find that B12 in a food source instead, for example, a fortified beverage might have B12 in it, that's a much better option than the vitamins that you get in a pill bottle because your body will more likely absorb those than they will the pill bottles. A couple others that you can find antioxidants, the vitamins A, E, C. They're considered antioxidants because they help your cells from being damaged. Certain chemicals, they exist in a very dangerous way called radicals. Um, if that happens, it just sucks because it breaks down part of your cells. But if you have A, E, and C, depending on what the free radicals are, they might be able to flatten those out and smother them so that they don't actually start causing damage. So it's good to have these in your body. Vitamin C in particular is really good to have. The way the free radicals work is that they donate an electron, so really, really tiny piece to your DNA. But if that happens, that can warp your DNA a little bit. And if the wrong piece of your DNA gets warped, that can be read as shutting off the apoptosis gene, and that causes things like cancer cell growth. Vitamin D, really good. Precursor to the molecule is in your skin. So you don't actually have vitamin D, it's in your skin. But when you have UV light, then you're going to feel good about it. Um, you can actually see this, like they test this by giving people vitamin D supplements and then sticking them in tanning beds, which have UV rays. If you put people in a tanning bed versus in just a bed that has artificial light, the people in the tanning bed will immediately well, people in the tanning bed won't say anything, but the people that are not in the tanning bed, they'll immediately tell you that there's something wrong because their body isn't feeling any different. Now, that's not saying you should go in a tanning bed because that much UV ray or UV radiation is awful for your body, but the sun provides a lot of it. So if you're outside, that's a way better option. You should avoid tanning beds if possible. Just using it as an example here. Vitamin D is often modified in your kidneys, and then it goes to your liver, and then eventually it becomes calcitriol, which is needed for calcium absorption. So if you want calcium in your body, you're going to need to use vitamin D to do that. Okay. A couple of minerals that your body needs. You should have more than 5 grams of each major mineral and less than 5 grams of each trace mineral. So you have both major minerals and trace minerals, depends on what they are. Things like calcium, phosphorus, these are going to be found in your bones and teeth. Doesn't necessarily mean you need to consume them to get into your bones and teeth. There probably isn't going to happen. In fact, lots of recent research shows that things like calcium does not get reabsorbed into your bone structure. It is used elsewhere in their body, so it is useful to have, but it's not going to make your bones stronger. It's not going to make your teeth stronger. Potassium and sodium, this is really good for nerve connection and conduction. So for those polarizations, you have to have potassium and sodium in your system. Sodium, no problem, your body recycles that. Potassium is the hard one. You need to get potassium salts into your body. Trace minerals, these are good for various enzymes and hormones, various small chemicals. So if you can get those in your system, it's good. Minerals are often found in colorful foods, so your fruits and vegetables just have a variety of them. If you have a variety, you're getting all the minerals you need. That's way better than using those pill bottle minerals. But if you don't have any other option, the pill bottles are okay as well. Here's a big one, calcium. Calcium is needed to have strong bones. That is actually a total bogus statement. It's actually false. It's just false. It's not true. For a long time, we believed that calcium was needed for strong bones because bones have lots of calcium in them. That's the reason we can get x-rays, because calcium can absorb those x-rays very well. And that's why when you take x-rays, you see bones because of the calcium. But there is almost no correlation to consuming lots of calcium and it getting into your bones. That calcium often doesn't get absorbed, it just gets excreted out of your body as it passes through. If it does get absorbed, it gets sent to other parts of your body for things like your nervous system or your endocrine system, but it is not going to help your bone structure whatsoever. So if anyone says that calcium is good for your bones, that is actually not that is not a valid statement. Uh, with an exception, if you have osteoporosis, so older women in particular are very prone to osteoporosis, then maybe it'll be useful to have free calcium in your system to help rebuild the bone if necessary. But I don't think any of you watching right now have osteoporosis, so you don't have to worry about that right now. If you're a pregnant woman as well, that might be also useful to have because quite a lot of your calcium storage is being sent into the baby in the uterus or the fetus in the uterus. So in this case, then maybe it is good to have some sort of calcium in the system. You don't need to get it from dairy; you can get it from other sources, but dairy is often seen as one of the most viable sources of getting that calcium in your system. You can also supplement calcium with vitamin D because they work really well together. Um, if this is specifically for bone loss, so if it is osteoporosis, you can also get birth control, which is synthetic estrogen that can help out as well. You got to be careful with synthetic products because there are some negatives as well, but we're not going to get into those just yet. Another one that you need to have is sodium, but you probably already have too much sodium in your body, so I don't think you need this. It's in every single food that we eat. It's an amazing part of all the preservatives that we use. So not the best thing because we've got so much of it already, but you do need to have a small quantity of it. If you're not careful with the foods that you're eating, you will develop some eating disorders. So, an example of one of those is obesity. If your body weight has a higher than 20% ideal weight, you are considered obese. And that's not good because it's slowing things down in your body. You're adding extra mass. That means that your blood vessels and your body systems have to work that much harder to move things around. That is consistent stress. And if that consistent stress lasts over, say, your lifetime, that shortens your lifespan because you can't have that much stress for that long. Your body even cracks at some point. Obesity can come from different places. It can be hormonal, so it could be because your endocrine system's out of whack. Often happens to teenagers. All of a sudden, you're supposed to grow taller, instead you grow wider. That's just something that happens. You can manage that though. You need to get control of your hormones in some way. Again, diet is incredible for this. Having good plans, workout plans are really useful for this because you can redirect that energy uses, that extra fat to other parts of your body. It could end up being a blessing in disguise if you want to convert that into muscle, for example. Could be a metabolic issue. Your metabolism will die out. For women, it'll start to die out either late in their 30s or after having a child. For men in their late 20s, your metabolism starts to die out. So if you ever have one of those friends that eats a cheeseburger and they never gain any weight, they have a really good metabolism system, but that will eventually die out. So just be careful with that. And also watch out for social causes. Depending on where you are in the world, the diets and the things that are around you might also affect the way that your body functions. If you're on the coast of China, for instance, they eat a lot of oily foods, which means you have a lot of oil in your system, which means you're going to add to that obesity. Whereas if you are living in, say, the northern part of the Netherlands, in this place, there's a lot of self-sustainability here. So limited meals, a lot of work. You're probably going to grow taller. You're going to grow a little bit stronger, but you're not going to get as much fat around your body. You're not going to be as obese as someone from other parts of the world might be. For a lot of people, if you're able to commit to a sensible diet, that's 90% of maintaining healthy weight. If you're able to add to that a good workout plan, a good exercise plan, then you can start to redirect some of that fat deposit into other parts of your body, into either muscle or respiratory growth. So just some things to keep in mind, and we can talk about that in class a little bit more if we need to. Another issue that you can get is the opposite of eating too much. You might have a situation like bulimia. Bulimia is a restrictive diet where people still enjoy the pleasures of eating the food or binging the food, but then they will eject the food from their body. They'll cause themselves to throw it back up. In this case, it's considered a mental condition, like it's something that is very, very wrong. with the mental makeup of your mind. So it doesn't mean there's something wrong with you. It just means that there's something that we can do about it. But you have to recognize that this is something that needs to be done. So if you've ever found yourself throwing up after eating, um, that's where you should ask for help. It could be someone like me, or it could be a guidance counselor, or if you have a nutritionist or a dietitian or a doctor that you can talk to. These are things that you can do. They'll help you out with some psychotherapy. They might give you some antidepressants if that's something that would be appropriate. But there's a couple of different ways that we can treat and get you out of bulimia. Another one to watch out for is anorexia. Anorexia is a distorted body image where you look in the mirror and you see any small little section of fat. And it's really difficult because this is one of those situations where your brain plays a trick on you, where even though you might be as thin as a toothpick, your brain sees skin, it sees a teeny tiny bit of fat on your body, even if you're less than 1% body fat, and it tells you you're too fat, in which case you stop eating and you start to get even thinner and thinner. And then your body just doesn't have the nutrients or the nutrition to function. So it's another really, really dangerous one that hits a lot of people. This is a growing one for young men, teenage boys, for example. So if this is ever a situation where you feel like you've got some eating disorders that you need to work through, same thing. The best thing to do is find someone that you're comfortable to talk to. I'm open to being one of those people if that's something you need to do, and then we'll find some sort of solution for that. The good thing is that there's always a solution for this. So you're never going to be stuck. You're never going to be alone in that. So it's something to keep your eyes out for. If not, it does become life threatening. It has the exact same threats as starvation, but it's something that often goes under the rug. You don't see it happening until it's too late because, a starving person, you can identify a starving person, but an anorexic person that is starving, that's a whole different story. So just something to keep in mind. We are at the end of our digestion notes now. So I'm going to pause here. I'm going to come back with a couple more notes on various different types of food products that we can get. So carbs, enzymes, proteins, that sort of thing. But we're going to pause here for now, and I'll see you guys in the next one. Thanks for watching.